Hello again, math friends. Today we're going to look at coin and ticket problems. Let's take a look at our first problem here. It says Tim has 22 coins in his piggy bank that are pennies and dimes. So we have pennies and dimes inside the piggy bank. The total amount of money in his piggy bank is 67 cents. We want to know how many of each coin does he have. So we need to know the number of pennies and the number of dimes. That's what we're looking for. Okay, we're told that we have 22 coins. A total of 22 coins. So the number of pennies and the number of dimes add up to 22. All right, let's say that I told you that there were 10 pennies. If I told you that there were 10 pennies, then how many dimes would we have? Well, you would take 22 and subtract 10, and that would give us 12 dimes. But we don't know how many pennies or dimes there are. So I'm going to call the number of pennies X. It doesn't matter. I can call the number of pennies X. I can call the number of dimes X. It doesn't matter. But whichever one I call X, the other one is going to be 22 coins minus the number of those coins. Remember, if I had 10 pennies, I had 12 dimes because I subtracted. Now let's go back to that little example. If I told you that there were 10 pennies and 12 dimes, and I wanted to know how much money that was, well, you would take 1 cent and multiply that by 10 pennies, and that would give you 10 cents. And then you would take 10 cents times 12 dimes, and that would be $1.20. So you would add that together and get $1.30. But we don't know how many pennies and dimes we have. So to take our number of pennies and dimes and find out how much money that is, we would take 1 cent times the number of pennies, which is X, add that to 10 cents times the number of dimes, and that gives us our total amount of money, which is 67 cents. So our equation is really 0.01x plus 0.1, I'm going to drop that ending 0 off, times 22 minus x equals 0.67. Okay, I don't really like to work with decimals, so I'm going to multiply this side of the equation by 100 so that it moves the decimal place twice right here. If I do that over there, I have to do that over here. So 100 times 0.01x becomes 1x. That's the reason for doing that, is so that the decimal place moves twice and we get rid of the decimal. Then we need to take 100 and multiply it by this. Well, that 100 is going to cause this decimal place to move twice. That gives us 10 times 22 minus x. On this side, the decimal place is going to move twice, and we get 67. So this gives us now an equation that we can solve. We need to first of all distribute the 10, so we get x plus 220, 10 times 22, then 10 times negative x is negative 10x equals 67. Then we need to combine like terms, so we get 220 x minus 10x is negative 9x equals 67. So now we're going to take and subtract 220 from this side. So we have 220 minus 220 minus 9x. We do that over there. We have to do that over here. These add out. We get negative 9x. And if we take 67 and subtract 220, we get negative 153. Let me write that again. We get negative 153. Now we're going to divide by negative 9, divide by negative 9. The negative 9's divide out. We get x. We take 153 and divide that by negative 9, and we get 17. So we take our 17, we put it back over here. That means we have 17 pennies. For dimes, we have 22 minus 17, which is 5. 17 pennies plus 5 pennies is 22 coins. If we take 17 and multiply it by 1 cent, we get 17 cents. If we take 5 dimes and multiply that by 10 cents, that's going to give us 50 cents. 17 cents and 50 cents is 67 cents, or in dollar form, 67 cents. All right, this time we're looking at a ticket problem. Ticket problems and coin problems are set up exactly the same way. We have, let's see, adult tickets and child tickets. So we have sold 320 tickets total. Okay, we're looking for the number of adult tickets sold and the number of child tickets sold. I need to call one of those X. I'll call the number of adult tickets sold as X. Remember on the last problem, if I give you sort of a setup already, what if I told you that there were 100 adult tickets? Well, if there are 100 adult tickets and there were 320 total tickets, then that means that there would be 220 child tickets that were sold. The way you got that was you took 320 and subtracted 100, and that gave you 220. But we don't know how many child tickets or adult tickets were sold. So if I call the number of adult tickets X, the number of child tickets sold was the total number of tickets minus the number of adult tickets sold. Then it gives us another important piece of information: how much each ticket sold for. So for adult tickets, these sold for $5. The child tickets sold for $1. They tell us that the theater brought in $1,120 in ticket sales. Well, let's go back to that little sample we did just a second ago. If I told you there were 100 adult tickets and we had 220 child tickets, and I wanted to know how much money we brought in, I would take 100 and multiply it by 5 and get $500. I'd take $1 times 220 tickets, and that would be $220, and we would add that up. But we don't know how many adult or child tickets were sold. So we called the number of adult tickets X, the number of child tickets 320 minus X. We brought in $1,120. So if I take $5 and multiply that by the number of adult tickets, and I take $1 and multiply that by the number of child tickets we sold, that would be our total amount of $1,120. So let's write this in a little bit more friendly looking equation. $5 times X is really 5X. 1 times that parentheses is just that parentheses equals $1,120. That $1 is an imaginary 1 sitting out here in front of that parentheses. So this is really 5x plus 1 times 320 is 320. 1 times negative x is negative x. Combine like terms, 5x and negative x is 4x plus 320. We need to get rid of this 320, so I'm going to do that by subtracting 320. These add out. And let's see, 1120 minus 320 is 800. Now we're going to divide by 4, and 800 divided by 4 gives us 200. So we're saying we sold 200 adult tickets, which means we sold 120 child tickets. 200 and 120 is 320. Let's see how much money we would make and see if it does add up to 1120. If I take 200 tickets at $5 a ticket plus 120 tickets times $1 per ticket, this is 1,000. This is 120. We get $1,120. Word problem, we should get a word answer. The number of adult tickets sold was 200, and the number of child tickets sold was 120. All right, now let's take a look at this problem. In this problem, we have a cash register. There are 455 bills inside the cash register. We have $1 bills, we have $5 bills, we have $10 bills. We want to know the number of each type of bill in the cash register. We have two key sentences here. The number of $5 bills is 35 less than the number of $1 bills. The number of $10 bills is 100 more than twice the number of $5 bills. There is no sentence that says the number of $1 bills is, so I'm going to call the number of $1 bills X. Let's go back to the first one. The number of $5 bills is equals 35 less than, means we're taking 35 away from the number of $1 bills, which is X. The next sentence is the number of $10 bills is equals 100 more than, means we're adding 100 to twice the number of $5 bills. The number of $5 bills is X minus 35, so twice means twice, 2 times, twice the number of $5 bills, twice the number of $5 bills. Okay? Then it says that the total amount of money is $3,115. So if I take $1 and multiply that by the number of dollar bills, and I take $5 and multiply that by the number of $5 bills, and I take $10 and multiply that by the number of $10 bills, that will give me $3,115. Okay, I'm going to clean this up a little bit. 2 times x is 2x. 2 times negative 35 is negative 70. And so this is really 2x plus 30. So I'm going to go back here and say that this is 2x plus 30. Just to kind of clean that up and make it a little bit easier to work with. So this is really 1x plus 5 times x minus 35 plus 10 times 2x plus 30 equals 3,115. So now I need to distribute, and I get x plus 5 times x is 5x. 5 times negative 35 is negative 175. 10 times 2x is 20x. And 10 times 30 is 300. That equals 3,115. X plus 5x plus 20x is 26x. Negative 175 and positive 300 is positive 125. I need to subtract 125. If I do that on this side, I must do that on this side. These add out. Get 26x. 315 minus 125 is 2,990. Divide both sides by 26. And 2,990 divided by 26 is 115. So we should have 115 $1 bills. 115 minus 35 is 80 $5 bills. For the number of $10 bills, 2 times 115 is 230, plus 30 is 260 $10 bills. We can check our answer by taking 115 times $1 and we get $115. Take $5 times 80 and we get $400. Take 10 times 260, $10 times 260 is 2,600. If we add that up, we get 3,115. Word problem, we should give a word answer. There are 115 $1 bills, 80 $5 bills, and 260 $10 bills. Okay, that wraps things up. Hopefully that cleared up some misconceptions. Make sure that you look at your key words, your key statements, set up your equations, solve the equations, go back and make sure you're answering the question. Make sure you check out all of our videos on our YouTube channel. You can search for Mathman1962. We also have at our EdTech website lots of free interactive math activities, drill and practice. Check it out on edtech.dnjdesigns.org. Thanks again, and we'll see you on the next episode.
If you liked this video, please click on the thumbs up. If you want to see more videos like this, please click on the subscribe button. And if you want to be notified when new videos are posted, please click the bell.